Hey, what's up, everybody? Welcome to this masterclass video with Bax Music. So, some of you might know me, some not, but let me introduce myself. My name is Umed Osken. I am a DJ, a producer, sound designer, a software developer. I'm signed to Spinning Records. I have my own label called Oz Records. And today in this video, we are going to talk about sound designing. Now, why is sound designing so important for a producer? We're going to talk about different kinds of synthesis techniques, how they work, and what kinds of sounds you can make with it. I'm also going to talk about my own VST plugin, what I've been working on for the last 8 years, called Genesis Pro. I released it last year in February. I'm going to show you how I created it, which program I used for that. I'll also do some sound design sessions to show you how to create certain sounds. I hope you guys are going to learn something from this video. Most of all, I hope you will enjoy it. So let's get started. So first of all, let's talk about why I think sound designing is so important for a producer. Now, before I got into synthesis, sound design, and developing my own software, I didn't know much about it. I knew how to make music, but I was always using the factory presets that was provided with any plugin or sounds that were created by other sound designers. Now, a downside of this is, of course, other producers use the same presets as well. And I mean, you can tweak it a little bit and change it a little bit, but it's still the same preset. And a good example of this is in the EDM songs nowadays. You can hear a lot of similarities in the leads, in the basses, in the plug sounds. This is because a lot of those producers are using the same presets. Only a few producers are capable to create their own signature sound. And that's because they know how to create their own sounds. Now, when I got into sound designing and software developing, I stopped making music for a couple of years and I just fully focused on learning everything about synthesis and sound designing and programming my own VST plugin. After a couple of years, I managed to create my first plugin called the Genesis that was released with Computer Music Magazine as a free plugin. So after that, I got into making music again, and then I noticed that it was a lot of easier for me to create my own sounds. I mean, when I had a sound in my mind, I just played around with some knobs and I had the sound I wanted. And it was really easy for me to recreate sounds that I hear in other songs. So at that point, I realized that sound designing is essential for a producer. Because as a producer, as an artist, you need your own signature sound. And when you have your own signature sound, you will stand out more as an artist. This is exactly why I think it's very essential for a producer to know sound designing. So the next thing we're going to talk about are the different types of synthesis forms. Now, you have many synthesis forms, but we're going to talk about the most common one, and that's going to be subtractive, additive, FM synthesis, of course, sample-based synthesis, wavetable, physical modeling, and the granular synthesis. So let's get over to my computer so I can show you some examples of different types of synthesis forms and explain to you how it works. Okay, so welcome to my computer. As you can see, I'm using ImageLine's FL Studio. I started using FL Studio way back when it was 3.0 or something. That's like maybe 20 years ago. Back then it was called Fruity Loops. And it was called Fruity Loops because you could make loops with it. And I really loved it because it was like the old school way of creating loops, like the hardware drum computers. And since then, I kept using FL Studio. I didn't change it. I tried Cubase, Reason, but I really felt like FL Studio is my thing. I really loved the workflow. It was quick and easy. Now, it doesn't really matter what kind of program you use, of course. They're all basically the same. They have the same functions, the same features. You just have to find the program that fits the best for you. Because at the end, it really depends on the person that sits behind the desk. Okay, so let's talk about the different types of synthesis forms. Let's start with the most basic one called subtractive synthesis. Subtractive synthesis is perhaps the most common form. And you start with harmonically rich sounds and then subtract harmonics from it with a filter. So usually you have 1, 2, or 3 oscillators, and you can choose between the basic waveforms like a sine, saw, ramp, triangle, pulse, or noise. And then you can mix those waveforms. You can play with the octaves and the pitch. You can turn on the filters. You can use some envelopes on your filter or on your volume, and of course you have some LFOs, depends on what kind of synth you have, and you use some effects, but that's it. And you can think of it like sculpting, like sculptor starts with a large block of material and cut away until it becomes something else. Now, subtractive synthesis is kind of the same way. You start with a raw tone with a lot of harmonics and shape it and form it until it resembles another sound. Now, a good example of a subtractive synth is the Mini Moog or the Roland Jupiter or the Arturia Mini Brute. Those are great examples of subtractive synthesizers, but of course there are many, many more. Now, the second type of synthesis will be additive. And to show you an example of that one will be the Morphine from FL Studio. Now, what is additive? Additive synthesis is considered as one of the oldest forms of sound synthesis. It's dating back to its application in the pipe organs. By controlling and routing the air through various pipes, it was possible to create a variety of timbres. So where subtractive synthesis involves starting with a very harmonically rich sound, additive synthesis is the opposite. Usually in additive synthesis you start out by combining multiple sine waves of different levels and frequencies, and as more sine waves are combined, they begin to generate additional harmonics. Now, an example we got here. Now you can add more harmonics to create more complex sounds. It depends on what kind of plugin you have, but as you can see, Morphine has more generators, so you can combine different generators. Now, the next form of synthesis will be FM synthesis, and this one is a little bit different. Let me grab the Genesis. So FM, which stands for frequency modulation, is a form of synthesis whereby one waveform modulates the other one. And instead of starting with a harmonically rich waveform, as in subtractive synthesis, usually FM starts with a pure sine wave called a carrier and modulates with another sine wave called the modulation. Now, this modulation creates harmonics in the audible carrier wave. Combinations of multiple carriers and modulators, so-called algorithms, create more complex sounds. And a good example of the FM synthesis is the Yamaha DX7. So let me try to show you an example. We have two sine waves here. Now this will be wave A and wave 1 and wave 2. So wave 1 is going to be the modulator and wave 2 is going to be the carrier. As I turn on the FM, you will hear the very recognizable FM sound. Let me turn on the filter. You will immediately hear changes in the second one. Also, this is the same technique to create the very famous deep house basses. Let me see if I can quickly make one. So FM synthesis is a very much used synthesis technique back in the 70s and the 80s, and it's still being used a lot, and it's also one of my favorite types of synthesis because you can create a lot of different sounds with it, from bells to basses to very glassy pads and sounds. So the next form of synthesis will be sample-based synthesis, of course. Now, sample-based synthesis involves recording of samples, a sound into a digital memory. And in the late 70s, early 80s, this was often a very expansive form of synthesis. Some of the first examples were the Fairlight CMI, which was a huge machine and was enormously expensive at that time. But of course, recently we have the very popular software versions, so-called Romplers. And good examples are, of course, Native Instruments, Kontakt, and RFX Nexus. So for those who are looking for ready-made sounds that can be tweaked a little bit, Romplers usually put huge sound libraries at your disposal without the need for doing any sampling yourself. Usually the Romplers, you have one or two oscillators where you can combine different samples. Now, sample-based synths can be useful when you're looking for natural sounds like pianos or violins or flutes. And it really depends on what kind of plugin you have. For example, in my VST, the Genesis Pro has also the option to use the sample-based oscillator. But as you can see, I added a lot of extra features, so you still can do your sound designing and change the sounds to your own taste. So the next synthesis form is a very popular one, especially the last couple of years. And a very good example of that will be the Serum. Now, of course, we're talking about the wavetable synthesis. Wavetable synthesis is a method of synthesizing sound using sample-based waveforms as oscillators. But instead of traditional oscillators, wavetable synths load each individual slice of a digital sample into a cell, or a so-called table. And then the synth scrolls or morphs the slices in the table, and the output is the sample as a sound. So the interpolation between those wave shapes is what creates the characteristic sound of a wavetable. And you immediately hear the very recognizable dubstep growl. So it's often used in music styles as dubstep. So that is a wavetable synthesis. So the next one I want to talk about is called the granular synthesis. And let me see if I can find, yes, here it is. I'm going to use the Fruity Granulizer. It's a very basic plugin, but it is the same synthesize technique, so I can use this one as an example. So what is granular synthesis? Granular synthesis is a kind of a sample synthesis again, but one that acts almost like a microscopically on the sample, breaking it down into tiny parts or grains and allowing playback to jump around different grains in the sample. Grain size, volume, position, etc. can be manipulated, resulting in creating new sounds. So, as granular synthesis can be a very powerful way to create new unheard sounds and textures. It is very often employed by sound designers for TV, movies, and video games. So let me see if I can show you an example. I've got a trumpet sample here, and I'm going to load it into the granulizer. So let me put some effects on it, make it sound a little bit better. Very quick reverb. Hitting a wrong note there, sorry for that. So, like I told you, this is a very basic example of granular synthesis, but you get the idea what is going on. Basically, this is like sliced up in very small parts, and you can manipulate the way you play those tiny parts. So the last synthesis form I want to talk about is called physical modeling. Now this one is very interesting. It's also a very old form of synthesis, but is recently coming back again. Now physical modeling is a synthesis method in which the waveform is generated using a mathematical model or a set of equations and algorithms to simulate a physical source of sound. Usually this is a musical instrument, but theoretically it can be anything you want. And so recently, plugins like Piano Tech, they created amazing results. I mean, now this is a piano, but these are not samples. All these sounds are computed, so it's digitally generated with mathematical models and equations and algorithms. But it sounds so realistic, it is almost unbelievable. As you can hear, the very low tones and the high tones. It sounds very realistic, and I think there is a lot of things possible with this kind of synthesis techniques. Theoretically, you can create any instrument, and there is also very good examples of realistic trumpets and brass instruments, string instruments, realistic guitars, and all these instruments sounds really, really, really good, like a really high quality and realistic. But the interesting thing is you can also create instruments which doesn't exist yet. For example, if you have a mathematical model, an equation of a trumpet, but you change the trumpet in a trumpet of 10 meters long, I don't know how it's going to sound, but you could do crazy stuff like that. So it's a very interesting technique. And also myself, I'm experimenting with this kind of synthesis, and I already had some great results creating kind of new sounds. So now you know some basics about different kinds of synthesis types. The next thing will be, how do you start creating your own sounds? How do you start sound designing? Now, I know every person is different, but the way I learned things is just by diving into it and start playing around and start tweaking it. Now, besides making music and sound designing, I also love to do 3D modeling and 3D stuff. I love to edit movies. I love to do even program my own games. Now, all of this, I learned it in the same way. Just start by nothing and do my own research and play with it every day. Now, sometimes you will get stuck and you will get frustrated because you don't have the results you want. At those moments, you can just search for a tutorial and find your way out. Now, I only searched for help only when I needed it. I think practice is still the best way to learn things. Now, learning how to use a synthesizer can be overwhelming. When you first start designing your own sounds, you can get confused with the dozens of parameters a synth has. But there are 5 main components that every synthesizer has. Once you understand these components, you will find your way to sculpt your sound. Now, every component has a specific role in the sound designing process. And when you understand these roles, you find your way to create the sounds you hear in your head. So the 5 components are as following. The first one is the oscillator. The second one is the filters. The third one will be the envelope section. The fourth one is the LFO, or so-called low frequency oscillators. And the last one is the effects section. So let's start with the first component, the oscillator. Now, this is the main component of your synth. This is where you generate your tones. Usually you can choose between different waveforms like sine waves, saw waves, pulse, triangle, Of course, it depends on what kind of synthesizer you have. Now, the second one is the filter section. Every synthesizer has a filter section. Usually you can choose between filter types like low pass, band pass, high pass. Now, with a filter, you're able to control the harmonic content of your sound. Or in other words, you can make your sound brighter or darker. Now, the third component is the envelope section, or ADSR, attack, decay, sustain, and release. With the envelopes, you can modulate your volume, your filter, pitch, and many more. So the fourth component will be the LFO, as its name implies low frequency oscillator. Now, the frequency range of this oscillator is much lower than we can hear, but it doesn't really matter because you use this oscillator to modulate different components of the synthesizer. For example, you can use it to modulate the pitch, that will be a vibrato effect, or you can use it to modulate a volume, that will be the tremolo effect, or use it on a filter to modulate the sound's timbre. So the last component is the effects section. Now usually synthesizers have effects like a delay, a reverb, a chorus to finish your sounds. But nowadays VST plugins and synthesizers have a huge list of cool effects. So now you understand the 5 components of a synthesizer. You're kind of ready to start designing your own sounds. Now, getting familiar with your parameters of your synth is only a way of practice. So the first step will be to identify the components in your synth. Now, every synthesizer is different, and there are many synthesizers out there, but they all use the same 5 components. So the best way to learn a synthesizer sometimes is just to reverse engineer a factory preset. Or you can start by an initialized preset. You will quickly notice how every parameter affects the sound. Now, creating sounds from scratch may not be necessary yet, but tweaking a preset is a good way to start. And it's also a good idea to start with only one synthesizer in the beginning, because all the synths are capable of doing the same stuff, but the way of achieving these results can be different. So the next thing I want to talk about with you is my own VST synth called Genesis Pro. As I told you before, I've worked on this for the last 8, maybe 9 years. And the first version of the Genesis was released back in 2011, I guess. It was a free VST. It got released with Computer Music Magazine. And then I decided to work on the second version, the Pro version. Only I had so many ideas and so many features I wanted to build in the synth that it costed me about 8 years. So finally, I released it last year in February. So you have to know that everything I know about sound designing and synthesis forms, everything I learned in Synthedit. And if you're a sound nerd like me, you should definitely check out Synthedit. Synthedit is a very cool program. It is a modular environment and it's visual programming. So you work with modules and you connect them with wires, and that's the way how you build your VST synth or your effect. Now the cool thing is you can literally build anything with Synthedit. I mean, your imagination is your own limit. And I have built many effects and synths, and I've got a lot of projects still got to be released this year. But like I said, if you're a sound nerd like me, you will definitely like it. And it's absolutely maybe the best way to learn about synthesis and sound designing. So in a bit, we will go back to my computer and I will show you how Synthedit works. I will try to build a very simple synth using those 5 components again I was talking about earlier. I will also show you the project of Genesis so you will get an idea how complex a project of 8 years of work looks like. So let's get back to the computer and let's get started. So welcome to Synthedit. As I told you before, Synthedit is a modular environment and it's based on visually programming. So what are we going to do? We are going to build a very basic synthesizer, and based on those 5 components, what I was talking about earlier. And so you will have an idea of how a synth is constructed from the inside. You will have an idea how everything is connected with each other. So the first thing we need is a MIDI input. So with this, we will be able to receive MIDI signals. Now, the next thing we are going to add is a MIDI to CV. Now, what is a MIDI CV? A MIDI CV is a converter, a bridge that converts the MIDI message or the MIDI signals to control voltage. And we need those signals to control the envelope with the gate. We need the pitch signal to control the pitch of the oscillator. You can control the velocity, the aftertouch. So let's connect the MIDI input. Let's enable Snap to Grid. Okay, so the next thing we're going to add is the first component, and that will be our oscillator. So here we got a oscillator, and this is a very basic oscillator. It has a sine, a saw, a ramp, a triangle, pulse, white noise, and a pink noise. So the first thing we are going to do is connect the pitch from the MIDI converter to the oscillator. So we can control the pitch of the oscillator with our keyboard. Let's add a list entry so we can control the waveforms. Make some space. So as you can see, we have a switch here, basic switch where we can control the waveforms of the oscillator. So the next thing we will need is a ADSR, or an envelope generator. Now, as you can see, we have a trigger, a gate, attack, decay, sustain, relays, and overall level input. As you can guess, we need to connect the trigger from the MIDI CV to the envelope generator, and the gate also. Now the oscillator has also some inputs: a pulse width input, a sync input, a phase mod, a PM depth, and with these two inputs you can create the FM synthesis. But that's not what we're going to do here. We're going to create a simple synth today. Okay, so the next thing we are going to add is the third component, that will be a filter. And we're going to add a simple filter, a state variable filter. Now, this is a very basic filter that has a low pass, a band pass, a high pass filter types built into it. So the oscillator output goes into the filter input. Like this. Now we need a slider or a knob to control the parameters. Oh, now let's connect this to the filter pitch. Now in SynthEdit it's called pitch, but you better know that as cutoff. And here we got the resonance. So let's rename this into cutoff. So we have a filter with a cutoff parameter. Now the next thing we are going to add is a VCA, or a amplifier, where we can control the volume of the oscillator, and we can control the envelope also. So the next thing we're going to do is connect the output from the filter to the amplifier and connect the envelope output to the volume input of the amplifier. So now we have the audio input coming in the amplifier, and with the ADSR we can control the envelope. So let me add some sliders to control the envelope as well. This is going to be the attack. So copy, paste. This is going to be the decay. This is going to be the sustain. The release and the overall level or the volume. Now, if I'm correct, if we turn on the synthesizer, we will have a basic synth with basic envelope controls and with a basic filter. Let's see if it works. And it works. So this is the cutoff. With this we can control the envelope. And here we can change the waveform. Let me put down the volume a little bit. So this is a very basic synth, but we still need to add two components. The next thing we are going to add is a LFO, a low frequency oscillator. Now the LFO is basically the same as a normal oscillator. The only thing that is different is the frequency range is going to be much lower. So what we want to do is create a switch so we can control the output of the LFO. We can choose what to modulate. We need a level adjust so we can adjust the amount of the LFO. Let's connect this here. So the first modulation target is the pitch of the oscillator. The second is going to be the cutoff of the filter. And the last one is going to be our volume. So now we have let's change the frequency scale of the LFO. And copy another slider, paste, connect this to the frequency. Let's make this 0.1. So it's a very low frequency oscillator. Let's have another knob slider for the amount. Let's make this 0.1 also. Okay, if I'm correct, let's add another switch and change its name. So this is going to be pitch, second one is going to be cutoff, and the third one is going to be volume. So now we have added the fourth component, and that is the LFO. We have added a switch where we can select the target to modulate with the LFO, and we have the LFO amount and the LFO speed. Let's see what is going to happen. Okay, so we need another switch to select the waveform of the LFO. So as you can hear, we have built a very basic synth. So now you have a little bit of idea how a synth works and how you build a synth. Basically, a hardware synths are built in the same way, only this is a digital version of it. But as I told you before, this is a great way to learn not only about sound designing, but how a synth is constructed and how it looks from the inside. And you will learn how to actually manipulate sound. And as you can see, it is really fun to play around with it. You know, it's like Lego. You can build whatever you want, actually. You know, you can do crazy combinations and try crazy stuff. I mean, like I said before, your own imagination is the limit right here. So we're only missing the last component, that's the effect component. I'm not going to add that right here. But yeah, I really recommend downloading SynthEdit and just have a play with it. And it will help you absolutely with your process of learning about sound designing and all kinds of synthesis forms. Now, the last thing I want to show you is how the Genesis Pro project looks like. As you know, we just built a very basic synth, and it was made with a couple of modules and a couple of wires. Now I'm going to show you how the Genesis Pro looks like. And I can tell you, you can hold your breath because probably you will be shocked. Now, keep in mind that this is a project of 8 years of work. And as you can see, that's a lot of wires. Now, I know it looks very, very crazy, but this is how it looks like. I mean, Genesis Pro is a very complete synth. So I built every function, every feature I had in my mind. And as you can see, all those containers, you can go in each container and you will get another screen full of modules and wires. And now it looks like a big mess because this version of SynthEdit is an older version, and it has some downsides. This is also the reason I couldn't make it 64-bit, because the hugeness of this project, and I couldn't port it to the newer version. But this older version didn't have the feature to snap the wires to the grid. But even if that was possible, it would still be a big spider web. So yeah, this is how a synth looks like from the other side. And I don't know, if I had to make a guess, maybe it's like thousands of wires. And at some point I started just with one module, like I showed you today in the example. I started with one module, and then I kept on building, and this is how it looks like after 8 years. Now you can imagine that I've learned a lot while I was building the Genesis. Now that is how the Genesis Pro looks like from the inside. You have an idea now how a synthesizer is constructed and how things are connected with each other, how the components work. So we have talked about sound designing and some ways to learn it. We have talked about different kinds of synthesis forms and how they work. So I don't know how experienced you are, but if you just get into sound designing, the best way to learn this is just to grab a synth you like and start playing around with it. Along the way, you will learn all those aspects of sound designing. And if you want to go a step further, then download a program like SynthEdit or something similar. You have also Flowstone Synth Maker, which is also a modular environment, and it is also based on visual programming. But a program like that will help you go way beyond sound designing. You will actually learn how a synthesizer works from the inside and how all those components are interacting with each other. So sound designing is a very essential aspect for a producer. It will help you to create your own sound. It will help you to recreate the sounds you have in your mind. And with that, you can create more original music. And like I said before, with sound designing, you're able to create your own signature sound. And because of that, you will stand out as an artist. So I hope you all learned a lot of this video. Most of all, I hope you guys enjoyed this video. I want to thank you all for joining me and hope you guys stay safe. Bye-bye.